Hello everyone. Today I am going to discuss the fourth problem of educational code forces round 162. So what is the problem? The problem is slimes. So there are n slimes placed in a line. The slimes are numbered from 1 to n. Okay. So there are n slimes. So now if what happens that every seconds exactly one slime eats one of its neighbors and increases its size by the eaten neighbor side. So let's take one example, you will understand it better. So let's say this is one example. So let's say there are four slimes. So any slime can eat any of its neighbors if its size is greater than of the size of the neighbors. So this slime can't eat any of its neighbors because 3 is greater than 2 and 4 is greater than 2. But this 4 slime can eat this left neighbor also and its right neighbor also. So let's say that the this third slime is eating the second slime. So after the operation the slimes will be like that 3 6 2. And after this will take 1 second. 1 second transformation will lead to this state. Now after that this sixth slime, the second slime, can eat the first slime also, so the state will be 9 2. Okay. So this will also take 1 second. So we have to find what is the minimum number of seconds. So the ith slime is getting eaten by any of its neighbors or any of the other slime. Okay, so that's what we have to print. So let's take this example only, 3242. So here you can say that the for the first slime to get eaten it takes 2 seconds. Okay, and for the second slime the 4 can directly eat it. So for the first slime the time is 2, and for the second slime the time will be 1, and for the fourth slime to be eaten, sorry, third slime to be eaten. So for that let's say our initial state is 3242. So 3 is eating 2, so it will be 542. After that 5 can eat 4. So this is 1 second, and after that 5 can eat 4. So it will take on again 1 second. So the third slime to get eaten, the total seconds will be 2, and the fourth slime to get eaten, this 4 can directly eat 2, so this will also be 1. Okay, so our answer will be 2 1 2 1. Okay, now I will not explain the other cases also, you can take a look at those cases again. So now let's look at some observations. So what observations we can make? So the first observation we will make is that obviously from the constants, so n is 3 into 10 to the power 5, and sum of n in over all test cases is also 3 into 10 to the power 5. So overall time complexity will be order of n, that is optimal, or order of n log n will also be optimal. Order of n or order of log n, or you can, I think, order of n log square n will also be working. But here I have solved the problem using this order of n log n. Now what is the second observation? The second observation is that when the answer will be -1. Okay, when the answer will be -1, answer will be -1 when no other slime can eat the current slime. Let's say this is like that, the slime array is like that, 2 2 5 2. So this third slime will never get eaten by its other slimes. Okay, so in that case answer of this will be -1, this will be 1, this will be 2, and this will be 1. So we have to find when the answer will be -1. Okay, the answer will be -1. First case is that all the slimes are of equal power, or you can say equal weight. You can say they say all are 2's. Okay, all are 2's or all are x's, then any two slime can't eat the other slime. Okay, but here let's say any two of the other slimes are not equal. Let's say like 3 2 5 2. Okay, now here again this is the second in next case, but here again this third slime is not getting eaten. Okay, this here again the third slime is not getting eaten. So what we are seeing that the first case is the prefix sum, or the prefix sum or the suffix sum. If it is less than the weight of the current slime, the prefix sum till I or suffix sum from I plus 1 to n, if it is less than equals to the weight of the current slime, then the answer will be -1 again. But let's say we are taking another example. Let's take a different color. So let's say our example is like that, 2 2 2 5 2. Now here you might argue that the sum of these three slimes, the prefix sum, is greater than 5, but here you have to consider that all the slimes are equal, so any two slime can't eat the other slime. So but let's say we have added any another slime 1 at the start, then the sum will be 7 and there is a possible formulation of a 7 weights rhyme. How? Let's say 2 eats 1, then this will be 3, then 3 eats 2, this will be 5, then 5 eats 2, this will be 7. So if there is a different number of slimes, different slimes, or let's say distinct slimes in the prefix or in the suffix, then only you have to consider the sum. Okay, but if the number of distinct slimes in the prefix or suffix is 1, then we don't have to consider those prefix and suffix. Now that is the second observation, that here we have to consider a prefix and suffix as the answer, possible answer. Let's say we have to consider something like let's say j to I, we have to consider j to I, not exactly prefix, but here you can see that from I we are taking j, or we have to take I to k. Okay, so here j less than I and uh, k greater than I. There are two conditions. We have to check the prefix sum of these two conditions, and we have to find the minimum j that satisfies the condition where sum from j to I is greater than, or here you can say that sum of j to I should be strictly greater than ai. And here also sum of not exactly sum of j to I, this will be j to I minus 1. And again for this case, for the suffix case, that sum of I plus 1 to k should be greater than ai. Now there is one additional condition we are saying, that all the elements, the elements from j to I should be they should not be same. Like here if we delete this one, then all the elements are same. So we have to consider the case when all the elements are same, then this condition will not be satisfied. Okay, now uh, we have, there will be one special case when ai minus 1 is greater than ai, and there could be a special case where ai plus 1 greater than ai. We have to handle these cases separately, because we are saying that from j to I minus 1 there will be there should be two distinct values, and we are saying that from I plus 1 to k there will be two distinct values. That's why we have to take these two cases separately, that ai minus 1, if this is greater than ai, then the answer will be 1, or this is greater than y, then the answer will be 1. These are the three cases. Okay, these are the three cases. So how for the third case is quite simple. We have to just take two conditions, two if statements, that if I minus 1 greater than ai, then answer return 1, or if I plus 1 greater than ai, return 1. In for the first two cases, we have to find a minimum j which is maximum j which is less than I and satisfies this condition, and minimum k which is greater than I and satisfies this condition. How we can do this? Obviously this sum formula, when all the elements are positive or 0, then this is this is monotonically increasing, so we can apply binary search here. So I will explain how I have implemented binary search here. For that, let's jump into the code. Okay, so here these are the two binary search, for one for checking left for the first condition, or once for the checking right for the suffixes. Okay, here I have taken these two conditions separately for check left and check right. So if ai minus 1 greater than ai, we are returning 1 in check left, and if ai plus 1 greater than ai, we are returning 1 in check right. Okay, now this part is for binary search. We are taking this left lei is important. So how we are using lei? Okay, lei will give us that the equal elements, right? Let's build lei for this array. Okay, so what we will do, uh, we will take that if the previous element is equal. So let's say the value will be 1 here. The previous element is not equal, so the value of this will be 2. But this element, the previous element is equal, so le of I will be le of I minus 1, this will be also 2. Now we are checking that this element is equal to the previous element, so the le of I will be le of I minus 1, which will be 2. Okay, but this element is not equal, so the le of this will be 1 2 3 4 5. Okay, this element is also not equal, this will be 6. That's how we are building the lei array. Okay, le array. Now after we have built the lei array, now how we can check that the any two elements that what are the number of let's say all the elements in a range are same or not. Okay, let's say we want to check that all the elements from I to j are same or not. So we will check that if le of j is greater than I, if LE of j is greater than I, that means that all the elements from j to I are not equal. But if LE of j is less than I, LE of j is less than equals to I, then we can say that all the elements from I to j are equal. So that's what we, for the equality check, that's what I am doing. That if for the check left, I am checking that if left of I minus 1 is greater than mid, so we are checking the range from mid minus I minus sorry, mid to I minus 1. That's why I am checking that if LE I minus 1 is greater than mid, then only we are setting answer equals to mid, and we are doing L equals to mid plus 1. Okay, and after our iteration is done, we are checking that if answer equals to infinity, then we return answer, else our answer will be the index of this j. So that's why we are returning absolute value of answer minus I. So the check right is also similar here. The range will be from mid I plus 1 to mid. That's why this condition will be checked for same values or not. And here p will obviously be the sum of the range, and if these two conditions are satisfied, then we are setting the answer as mid, and we are checking in the left half. Okay, so here I am building the prefix sum array and the LE array, and I am taking L answer as the check left and R answer as the check right. I am taking answer as a minimum of left answer and right answer. If answer is still infinity, then our answer will be minus 1. Okay, I hope you got my explanation. This problem is quite interesting to me. I will provide the link of the code also in the description box. If you find this video helpful, please like the video and subscribe to my channel. Thank you.